Hi, all of you. So, in this lecture, we will study ydse with glass slab. So, we'll derive some formulas, we will understand some concepts related to this topic, and I'm sure that after watching this video, you will definitely able to solve all the numericals related to this topic. Before starting this, I want to say that you must be aware of what is optical path length because it will be used in this topic. So, if you are not aware, then you can go to my content and you can watch the optical path length video and after watching this you will able to understand this video very clearly. Okay, now इसमें हमने क्या किया है? We have inserted a slab of refractive index mu thickness t in front of slit S1 and this is slit S2. This is an air and we will observe the pattern on the screen. So let's say at this point, what is happening at this point? So two waves will travel, one from S1, one from S2, and there will be seen some pattern at P. So we have to write what is path difference because path difference will tell what will happen at P. The path difference is distance traveled by S2 wave, distance traveled by S1 wave, and the difference of these two waves is called path difference. Now, what is optical path length? It says that when a light ray travels in a medium of refractive index mu, thickness t, then we take that distance as mu t. So if a light ray is traveling in a medium of refractive index mu and length t, then we will take that distance as mu t. This is optical path length. So what I will do, I will write S2p because it is completely in air. And when I will write S1p, I will write first of all S1p minus t. I love this length, this one plus this one. So this is S1p minus t कर दिया हमने इसको plus. Now this distance is considered as not t but mu t by this concept. So first of all I have added the air distance, then I have added the mu t distance because in this medium it will travel mu t distance. So this will be the optical this will be the part difference. Now I will write S2p minus S1p and minus mu minus 1 into t. Now what is S2p minus 1p? So this we can calculate. Yeah, this we calculates from ydse कि ये कितना होगा, ये gap कितना होगा. So this gap turns out to be this distance because ये d बहुत बड़ा होता है. D is very greater than small d. तो जब हम इस gap को निकालते हैं तो we draw a perpendicular on S2, S2p. So this is the difference because these two lines are almost parallel lines because this is point is very far away. So to calculate S1p minus S2p, we draw a perpendicular and this is the distance. And this distance we know that this is d sine theta, or you can say कि angle is small, so d sine theta, or this is d tan theta. And tan theta you can calculate because this is angle theta actually from center. This is y and this is d. So this is actually dy by d. So you can write here dy by d minus mu minus 1 into t. Now this is the basic concepts of ydse, so you must be aware of this. And this will be the part difference at t. So you can see ki when no slab was there, then this was the part difference only. When we have introduced a slab, the part difference changes and becomes this. So this is the extra factor. Now, let's say ki for maxima, maxima or bright fringe. For bright fringes, the part difference must be equal to n lambda. So we just put the formula dy by d minus mu minus 1 into t is equal to n lambda, and dy by d is equal to n lambda plus mu minus 1 into t y equal to n lambda d by d. So this will be the location of maximas. So this is the extra factor coming here. When we don't have slab, then this was the location. Now this plus, now the location has changed and this extra factor has arise here. Okay, now what we have to find central maxima. So n equal to 0, we can put central maximum. So we will get n0 for mu minus 1 into t d by d. For first maxima y equal to lambda d by d plus mu minus 1 t d by d. Similarly, we can calculate for n equal to 2 as well, second maxima. So 2 lambda d by d plus mu minus 1 t d by d. So we can see when there was no slab, then central maxima was there at y equal to 0. First maxima was at lambda d by d. Second was at 2 lambda d by d when no slab was there. When we introduced slab, central maxima was not at this y equal to 0. This will be at this distance. So this is the shift actually. Mu minus 1 t d by d. This is the n equal to 0 central maxima. Now first will be equal to just mu minus 1 t by d plus lambda d by d. So we can add plus lambda d by d. We will get n equal to 1 first. Then similarly we can again add plus lambda d by d. So we will get n equal to 2. So we can say that the whole pattern, the normal locations are this y equal to 0, lambda d by d, lambda 2 by d. But here, this extra distance comes. So we can say that the whole pattern shift towards the side where slab is introduced by a distance mu minus 1 t d by. So this you can learn ki bhai, the normal location, let's suppose ki normal formula for maxima are n lambda d by d. So if we have to calculate ki bhai fourth maxima nikalo, fourth maxima, so we will put 4 lambda d by d and just add this value. So you will get location of fourth maxima when slab is introduced, for slab only. Without slab, this was the answer. Okay. So similarly, you can calculate for minima as well. So part difference was dy by d minus mu minus 1 into t. For minima, this is 2n plus 1 lambda by 2. So y will be equal to 2n plus 1 lambda d by 2d plus mu minus 1 t d by d. So you can see ki here also this is the extra distance which is similar to the maximum shift. So this minima will also be shifted. So the net, we can draw the net positions. So this is central maxima n equal to 0, mu minus 1 t d by d. Then if we move lambda d by d up, we will get first maxima. Then we move again lambda d by d, we will get second minima. And in between these, there will be first minima, there will be second minima. So the whole pattern shift, this is the simple point, the whole pattern whole pattern, every fringe will shift by the distance. That's it. Right. One more thing we can calculate here, the number of fringe shifted. Because this type of question are very much asked in JEE main, ki how many fringes will shifted. So you can see ki when normal ydse without slab, central was there, y equal to 0. When we have introduced slab, central comes here, central यहाँ आ गया at this point, तो mu minus 1 t d by d. फर्स्ट यहाँ आ गया, सेकंड यहाँ आ गया. सो नंबर ऑफ फ्रिंज शिफ्टेड, कितनी फ्रिंज ऊपर शिफ्ट हुई, दैट मीन्स कि इन दिस डिस्टेंस देयर वाज सब फ्रिंजेस अर्लियर, मतलब यहाँ पे कुछ फ्रिंजेस एग्जिस्ट कर रही थी पहले इस डिस्टेंस में, वो सारी ऊपर शिफ्ट हो गई, दैट ऑल शिफ्टेड अपवर्ड, है ना. सो वी हैव टू कैलकुलेट कि नंबर ऑफ फ्रिंज कितनी शिफ्ट हुई, ये बिकॉज पहले सेंटर वाली फ्रिंज होती दैट वाज हेयर ओनली, वो यहाँ लाई कर रही थी, अब ये ऊपर चली गई है, तो इस डिस्टेंस में कुछ फ्रिंजेस थी 5 6 7 जो ऊपर चली गई, तो कितनी शिफ्ट हुई. सो दिस वी कैन इजिली कैलकुलेट कि भाई जो आपने निकाला है म्यू माइनस 1 टी डिवाइडेड शिफ्ट जो निकल के आया इज इक्वल टू एन इंटू फ्रिंज विड्थ, कि एक फ्रिंज की विड्थ कितनी है. मतलब लेट्स सपोज कि दिस वैल्यू कम्स आउट टू बी 4 एंड फ्रिंज विड्थ इज 1. सो वी कैन से कि भाई वन फ्रिंज की विड्थ तो 1 है, और टोटल जो शिफ्ट की रेंज है वो 4 मीटर की है, तो 4 फ्रिंज शिफ्ट हो जाएंगी, तो वी हैव डन विद एन बीटा, एन वी कैन राइट एन. सो एन इज इक्वल टू mu minus 1 dd by d upon beta. We can put beta here. So mu minus 1 into t d by d, and beta is lambda d by d. So d से d cancel हो गया, is equal to mu minus 1 into t by d. So this formula will give you number of fringe shifted due to introduction of slab. Okay, now this was about for one slab. I hope you all understand this topic. Now, if let's suppose ki two slabs are introduced, so just I will write down the formulas and show you how to derive these. Let's suppose this is mu1, this is let's suppose t1, and this is mu2, and this is t2. Now we have to calculate part difference p, s1, s2. So I will write delta p, delta x equal to s2p minus s1p. Now s2p is s2p minus t2. So similarly we have written without slab कि भाई इस रे ने जो आपके पास ये रे जा रही है, इसने विदाउट स्लैब कितना ट्रेवल किया, तो एस टू पी माइनस टी टू प्लस दिस medium, that this distance is similarly mu 2 t2 by optical path length. Now similarly we can write s1p minus t1 plus mu 1t. Now s2p minus s1p plus mu 2 minus mu 1 into t, or plus t1 minus t2. This is the part difference. Now we know this value. This is similarly by d sin theta, या फिर dy by d. So part difference is dy by d plus mu 2 minus mu 1 into t plus t1 minus t2. This is the part difference. Now if question says कि find करो first find करो maxima की conditions, maxima condition, so you just do delta x equal to put n lambda, and you can calculate these all values. If question says कि find central maxima, सेंट्रल मैक्सिमम मतलब where part difference is 0. So you can calculate delta x equal to 0 put. So you will get some value. So you can calculate everything, first maxima, second maxima, third maxima, central maxima, every value by using this formulas. So you need to just calculate part difference at any point that you know, I think. So this is all about introduction of uh, slab in ydse. So please comment on the video. And for more such informative videos, just like my channel, like my video, subscribe my channel and share it. Thanks for watching.